Solenoid practice 1. For each figure at right, indicate the north and south poles of the electromagnet. Stop the video if you want to try this on your own before I go into it. But the right-hand rule for solenoids and figuring out which pole of the electromagnet is the north pole is that you let your fingers of your right hand curl in the direction around that center part, and whatever way your right thumb points, that's the north pole. If you look at this one in the upper right here, you can see by the diagram that the wire, first of all, it's carrying current in this direction because that's the positive terminal of the battery, and then the current is coming this way. And you can see that it is behind the center here, and now it's coming towards us, and now it's behind. So if you get your right fingers out, we're behind that center portion, and now we're coming towards us like this. So that means that the north pole is that side, the south pole is that side. How about this next one? You can see the current is traveling to the right here in the direction my marker is pointing, and here we're on top of the core, and then we're going behind the core. So for this diagram right here, if you watch the fingers of my right hand, we're on top of the core down there at the bottom, and then we're curling around behind. That means that my right thumb points that way. A couple more. Here we have the current traveling this way. We're on top of the core here, and then we're behind the core after. The right hand for this diagram is going to be, my fingernails are closer to us now, and now we're going away like that. The right thumb points that way. And finally, what do we have here? We've got current that is behind the core, and now it's towards us, and then it's behind, and then it's towards us. Your right hand, the fingers are behind, right? See my fingernails, and now they're coming towards. That's what we showed right there. I'm thinking that the north pole is on the right side like that. Let's label the north and south poles of this horseshoe magnet, and let's draw magnetic field lines outside and inside the magnet. You can see by our little schematic here that the current is going to be traveling that way around the circuit. And if we use our right hand rule, that means that we're going to end up with the north pole being that one and the south pole being that one. It's the same idea. It's kind of hard to do here because the current is going around that way. So my fingers are going to curl in the direction that the current is traveling around there. And so that means that the north pole is going to be on the top. And we know that magnetic field lines outside of a magnet go from the north pole to the south pole. Probably there'll be some fringing here that takes place, something like that. We could draw a whole bunch of these if we wanted. But inside the magnet, the magnetic field lines actually travel from the south pole to the north pole, right? These are continuous loops here, and they never cross each other. They never cross, and they never get tangled up. I can't draw them all, but that's how you go. Let's do a couple more here. Which diagram is a correct depiction of magnetic field lines created by a current flowing in a solenoid? Well, are there any of these that we can eliminate? I think we can eliminate this one because this one is showing field lines going in the sort of counterclockwise sense, and then these going in also in the counterclockwise sense, and that's not how they would have to go if we're above and we're below that core. So that one can't be right. And what other one can't be right? This one here can't be right. It's between these two. And which one are we going to do here? Well, let's look at this one in the upper left. We've got the current traveling this way, and if you use your right hand rule for solenoids, hopefully you can see that this would be the north pole of the magnet, and this would be the south pole, and that is not how field lines go, is it? Outside the magnet, they go from north to south, and here we're showing from south to north. So it has to be this one in the lower right, but let's verify it to make sure. We're seeing the current in loops going around the core there, which means that The North Pole is going to be at that end, and the South Pole is going to be at that end. There you go. Let's do one more here. Which of these terminals is the positive terminal, and which one is the negative terminal, where we're going to use our right-hand rule, and our thumb is going to point towards the North Pole. So they've given us that, and that means that our fingers need to curl in the direction that the current is going around that core. So it appears that current must be traveling this way around the core in order for that right-hand rule to be satisfied. So I'm thinking that A is the positive terminal, and then B is that negative terminal. We could label them if we wanted.